All right, hello everybody. We're going to jump into our next topic, which is going to be on POPs and PCPs. Just so you know, we are skipping a few sections in the notes, so you might have to scroll down a bit to get to it. I just like teaching it in this order, but we will go back and cover those notes later. But if you're trying to follow along with your notes, I did skip ahead a little bit here. So, POPs, which is going to be the main topic for today, are going to be another classification of water pollutants that we're going to talk about. And these are synthetic components that do not easily break down, which means they accumulate in the environment. So POP stands for persistent organic pollutant. Persistent because, like I said before, it lasts for a long time. Organic because they contain carbon molecules. So, for example, in this one, which is DDT, you can see the carbon here. There's some in these rings as well, some carbon there. And they're pollutants because they have negative impacts on the health of not only us, but other organisms as well. So, what makes POPs so persistent is that they are fat soluble. And what that means is that they can build up in organisms over time. So, if you consume something that has POP in it, or maybe you breathe it in because it's a pesticide, and it somehow works its way into your bloodstream, it does not fully get digested by the liver, and it doesn't really mix easily with blood or urine. So what happens is these POPs are going to get instead accreted into fat cells. So they kind of build up and are stored there. Typically, POPs are the most dangerous when an organism is burning fats because then those POPs get re-released back into the organism and can cause certain disorders. But mostly for this course, we're not going to get too much into the medical side of it. Mostly just understand that these accumulate in fats, which means they're not removed from the organism like other pollutants are at the rate at which they are taken in. So POPs have a lot of anthropogenic sources. The big ones that you need to know for this is industry, pesticides, and medicines. Those are the big three categories we talk about here. Some more specific examples include things like DDT, which is an insecticide, PCBs, which are plastic and paint additives. You have fireproofing and plastic additives for BPA. That's why on some water bottles you might see BPA free. It's essentially saying it doesn't have this persistent organic pollutant. There's some from fertilizers and the combustion of waste from biomass. Again, plastics, and then also from rocket and missile fuel fireworks. So you can see there's a couple here that come from plastics. That's because plastics tend to have these organic, they tend to be carbon based. So as they break down in nature, they can easily accumulate in organisms. Now, the other thing that makes POPs so dangerous is that they can move through biogeochemical cycles pretty easily, and they can move through both biotic and abiotic sources. So here we can see the red a pesticide being applied, and the red arrows kind of show the POP being moved. So it moves down into the soils. It can be uptaken by plants because it's organic, which means it works its way into the leaves. Leaves go back into the soil and decompose back in here. From the soil, it can also go into groundwater and eventually work its way up and then taken into the water cycle up here. So these POPs just randomly move around these biogeochemical cycles, which means eventually they're most likely going to work their way into food webs as well. Now, POPs, the reason they're dangerous for organisms is because they can cause a lot of different health effects. For example, some of them are endocrine disruptors. Some can lead to cancers and are carcinogens. In aquatic organisms, typically they're going to lead to reproductive problems, which is what we talked about in the past. It can also lead to health issues like obesity, cardiovascular problems, and diabetes as well. Now, as these POPs work their way into the food web, they're going to do something called bioaccumulation and biomagnification. So I'm just going to skip down real quick here, down to this. And essentially, what that means is as these POPs work their way through a food web, they're going to increase in concentration as you go upward. Okay, and we refer to this upward increase in concentration of POPs as biomagnification. So in the lowest part of the trophic level, and water is not technically a trophic level, but in the environmental concentration, we can see that POPs tend to be in low concentration. However, plankton, as it does things like photosynthesis, or maybe this is zooplankton eating other things, they're going to take that DDT in over its lifespan and slowly increase in concentration in it. And this is what we call bioaccumulation. Well, those are going to store in the fats long term tissues within the plankton, which means it's going to be consumed by the fish. So the fish is not only taking DDT from its environment, but it's also eating multiple plankton throughout its life that has a higher concentration. And as you go up the food web, you can see the concentration increases more and more. Okay. So we have bioaccumulation, which is the buildup of chemicals over time. It's supposed to be here. We may make some edits. So you have bioaccumulation. Oh, here we go. We have bioaccumulation, which is the buildup of chemicals over time in a single organism. And you have biomagnification, which is an increase in concentration of chemicals through trophic levels. So you do have an FRQ today. Let me go back up here. So this is explain why PCPs, also known as POPs, into an aquatic ecosystem may have longer lasting negative impacts on the organisms than the release of synthetic nitrates. All right, so that's going to be your FRQ. Think about why POPs are more dangerous than other pollutants, and I will see you all tomorrow.